Wait. Yeah.
Okay, so this is a final exam review for Developmental Math 1. So I'm going to work through a final exam review that you could get. There'll be very similar questions, and then we're going to just work through. And if you have any questions, just stop me. Okay, so we'll start with number 1. So number 1 says to simplify. And we have 3 plus 3 times 8 minus 4 minus 1. Okay, so whenever you're simplifying any expression, you always want to use order of operations, which is PEMDAS, or please excuse my dear Aunt Sally. So P represents parentheses, or any grouping symbol. E represents exponents. M and D is for multiplication.
And then multiplication.
Multiplication and division.
So you solve first
and then A and S represent addition and subtraction. Okay.
4 and then exponent.
So this tells you the order that you do your steps in. Now keep in mind that multiplication and division and addition and subtraction have equal weight. It depends on which you see first from left to right. Okay? So let's get started. So we have parentheses here. We have 8 minus 4 in parentheses, so we want to simplify that first. 8 minus 4 equals 4. And so I'm going to write everything else around that.
Okay.
So now I have 3 plus 3 times 4 minus 1. So now we've taken care of any parentheses. We do not have any exponents. So now we need to check for any multiplication or division. So we do have some multiplication here.
Where?
And that is right here. 3 times 4. 3 times 4 is 12. So now we're going to bring down everything else. And so now we've taken care of any multiplication and division. So now we want to check for addition or subtraction. And we're going to do whichever we see first from left to right. So we're going to start off by doing 3 plus 12, which is 15. And then we have bring down that minus 1. And so 15 minus 1 is 14. So your final answer is 14.
Okay. Okay, yeah, that was
okay. All right. Number 2. So we're going to simplify again. 7 squared minus 6 squared, all divided by 7 minus 6 squared. Okay, so when you have a fraction or a rational expression, let's simplify the top and then the bottom before we do the division. So we have parentheses. So we can look at these as like 2 separate expressions to simplify, one at the top and one at the bottom. So at the top, we've got 7 squared. So 7 squared is the same thing as 7 times 7, which is 49.
Okay.
And then 6 squared is 6 times 6, which is 36.
36, yeah. All right.
Okay, divided by, now here, 7 minus 6 is in parentheses, so we want to do this first. 7 minus 6 is 1, and then 1 squared is 1 times 1, which equals 1. So we have 1 in our denominator. At the top, we have 49 minus 36. So now let's do 49 minus 36. 9 minus 6 is 3. 4 minus 3 is 1. So 49 minus 36 equals 13. And we have 13 over 1, which is the same thing as saying 13 divided by 1, which equals 13.
13, right. Mm-hmm.
All right?
Yeah.
Oh, Jesus. Okay. Number 3. Determine the prime factorization of 300. Okay, so for something like this, I'm going to use a factor tree. So I'm going to start by writing 300, and I want to think of two numbers that multiply together to give me 300. And you can start off with any two numbers that multiply to give you that number, as long as you pick two numbers that actually do multiply to give you that number. So I'm going to do 30 times 10, because 30 times 10 equals 300. So I'm going to break down every factor into smaller factors until I have nothing but prime numbers. So 30, I can break that down into 6 times 5 equals 30.
Right.
10, I can break that down into 5 times 2 equals 10. 6, I can break down further. 3 times 2 equals 6. 5, I can only break that down to 5 times 1, because 5 is a prime number. The only number that can be divided evenly into 5 is the number 5 and 1. And then 2 is also a prime number. So I have now factored 300 all the way down to a prime factorization. So let's list this in order from smallest to largest. So I have 2 times 2 times 3 times 5 times 5. But we can use exponents for repeated factors. So 2 times 2 is 2 squared. We just have 1 3, so times 3. 5 times 5 is 5 squared. So this is going to be the prime factorization of the number 300. Okay? So we start with a factor tree. We break that down into nothing but prime numbers, and then we list out those numbers from smallest to largest. And whenever we have a repeated factor, we use exponents. Okay. Number 4, we're going to graph x is greater than or equal to -4. So we want to graph that on a number line. So I'm going to put -4 in the middle. And let's think about the values on the left and right side of -4. So the values less than -4 are going to be on the left. So this would be -5, it could be -6, and so forth. Values to the right of -4 on the number line are greater than -4. So this would be -3, -2, -1, say 0. So because we have this is greater than or equal to. So this tells us that we're going to use a closed dot over the number -4, because we are including -4 in our solution. So we're going to put a closed dot over -4. Now this says that x is greater than or equal to -4. So the or equal to part is why we use the closed dot. Now, where are the values greater than -4? Well, they are to the right. So we're going to shade all of the values to the right to represent the solution for this inequality. It could be any number to the right of -4. And it could also be -4 because it's greater than or equal to. So for this problem on the final, it'll probably be a multiple choice problem that you'll need to select the correct graph to get the right answer. Okay? All right. Okay. Number 5. So we're going to compare numbers. So we have -4 compared to -13. And we're going to enter greater than, less than, or equal to in the box. So -4 is actually greater than -3. Because if you were to put that on a number line, yes, so positive values, say this is 0. Let's say this is 5, 10, 15, right? So positive integers, as you get bigger, the actual integers get bigger. But if you go to the left to negative, so this is -5, -10, -15. Let's think about where these numbers will go now. -4 would be somewhere over here. And then -13 would be between -10 and 15, so somewhere over here. So on a number line, your numbers are going smallest all the way up to largest. Okay? So since -13 is on the left side of -4, it means that -4 is greater than -13. Another way that people kind of remember which sign is which, they'll say the alligator opens its mouth to the bigger food. So this would be saying that -4 is greater than -13. All right? Any questions about that? Okay. All right, number 6, simplify 12 minus -8. Okay, so you can look at this a few ways. You can look at this as saying minus a negative. It's the same thing as saying negative times a negative. Or we can think about our rules for subtracting integers. So when you subtract integers, hold it there. Okay, so when you subtract integers, you want to change it to adding the opposite. All right? Okay, so here we are subtract 12 minus subtracting -8. So to add the opposite, we want to keep the first thing the same. So 12, change subtraction to addition, plus, and what's the opposite of -8? +8. So 12 minus -8 is the same thing as 12 plus 8. All right? And so 12 plus 8, 2 plus 8 is 10, carry the 1, 1 plus 1 is 2. So your answer here is 20. All right? Okay. Question 7. This is 5 times -2. So remember, when you are multiplying or dividing integers, when they are the same signs, it's positive. And when they are different signs, it's negative. Those are the simple rules for integers when you're multiplying and dividing. So here, 5 times -2, we have different signs. So that means our answer, our multiplication answer, our product is going to be negative. So now, what's 5 times 2? 10. So the answer here is -10. Let's look at 8 right here. So we have 15 plus 40 divided by 8 minus 3 times 2. So let's think about our order of operations. So there's no parentheses, so we can check that off the list. There's no exponent, so we can check that off the list. We do have multiplication and division. So remember, when you have both, you do whatever comes first from left to right. So let's see, we have division here and multiplication here. Which one's coming first from left to right? This division. So you want to do this first. So 40 divided by 8 is 5, because 5 times 8 equals 40. Now let's bring down everything else. So it's 15. That was a positive 5. Then bring down that -3 times 2. Now check and see if we have any other division or multiplication. And we have multiplication. So now, so now the sign that comes in front of the number goes with that number. So this is -3 times 2. So we're multiplying different signs, so the answer is going to be negative. And so 3 times 2 is 6, so -3 times 2 is -6. And then we're going to bring down everything else. And so now we've taken care of any multiplication or division, and now we're looking at addition or subtraction. And you do whatever you see that comes first from left to right. So here we have addition first. So 15 plus 5 is 20. And then we're going to bring down that -6. And then 20 minus 6 is 14. All right. Any questions about this one? Let's see. Number 9. Simplify the absolute value of -198. Okay, so the absolute value of any number is going to be a positive value. So this is going to be just positive 198. So remember that the absolute value, these are these two lines on the outside, represents the distance that number is from 0 on a number line. So if we have a number line, here's 0. If positive 198 is to the right, that means that negative 198 is to the left of the same distance. So if I were to like count the units, if I were to go like this, however many times, to go from here to here, that would be a distance of 198. So that is why the absolute value of -198 is positive 198. So that's your answer, positive 198. Okay, let's look at the next one, number 10. We're going to simplify 5 times -1 minus -1, close brackets, plus 7. Okay, so this is another order of operations problem. Now, P represents parentheses in this mnemonic, but that's just meaning grouping symbols. So the reason why we have brackets here is because we're already using parentheses, and so you don't normally see multiple sets of parentheses in one problem. So if you have to have parentheses inside of parentheses, then the outside will become brackets, just to make it look more clear. So for parentheses, for this case, that just means grouping. So we're going to look at this first group here. Okay? So within these brackets, I'm going to simplify. So -1 minus -1. So remember, we can change that to adding the opposite. So we keep the first number the same, change minus to plus, and then what's the opposite of -1? +1. So that is what we're going to do inside that bracket. So -1 plus 1 is actually 0. So now we have 5 times 0 plus 7. Now, from left to right, you check for any multiplication and division, and we have multiplication. So 5 times 0 is 0. We're going to bring down that plus 7. And then 0 plus 7 equals 7. So the final answer for that problem is 7. Okay. So let's keep it moving. Number 11. Simplify. 3 times -5 plus 7 plus 6 times -3 plus 8. Okay, so we're going to, again, you're going to have quite a few order of operation problems. So that's why you're going to see it a lot in the review. So we're going to work within the parentheses first. So I've got -5 plus 7. So when you are adding integers, if they are the same signs, you keep the sign and just add the numbers. If they're different signs, you take the sign of the larger number and then find the difference between the two numbers. So this is -5 plus 7. So they're different signs. So that means we want to take the sign of the larger number. So the larger number is 7, so our answer is going to be positive. And so what's the difference between 5 and 7? 2. So -5 plus 7 is positive 2. Okay? Now let's do this other set of parentheses. So they have different signs as well. So we're going to take the sign of the larger number. So which one's bigger, 3 or 8? 8 is bigger. So my answer is going to be positive. And then what's the difference between 8 and 3? 5. So it's going to be a positive 5. And I just wrote everything else around those numbers. So now going from left to right, we check for any exponents, which we don't have. Now we check for any multiplication or division. We have multiplication here, so we're going to take care of that next. So we have 3 times 2, which is 6, plus 6 times 5, which is 30. And then now we just want to add up 6 plus 30, which is 36. So 36 is going to be your final answer. Okay, let's look at number 12. Okay, so we have 6 minus 5 squared. So again, order of operations. So we don't have any parentheses. We do have exponents. So now we want to address this exponent. This is 6 minus 5 squared. Whatever is directly to the left of the exponent is the base. So in this case, the base is just this positive 5. Now, I want to do a little side note. Okay, negative 5 squared is not the same thing as negative 5 in parentheses squared. This is very important to talk about. So, negative 5 squared is not the same thing as negative 5 in parentheses squared, because what this first thing is saying is negative times 5 squared. Because remember I said whatever is directly to the left, whatever is touching the exponent is the base of the exponent. So what this is saying is negative 5 times 5. Okay? What this is saying on the right is saying, okay, the parentheses is directly to the left, so that means that what's in the parentheses is the base. So this is saying negative 5 times negative 5. And those are saying two very different things. Negative 5 times 5 is negative 25. Negative 5 times negative 5 is positive 25. So going back to the problem that we have, this is going to be 6 minus 5 times 5. Alright? So now, 5 times 5. This is actually negative 5 times 5. So negative 5 times 5 is negative 25. So it's going to be 6 minus 25. So now we are subtracting numbers. Let's change that to adding the opposite. That'll be 6 plus the opposite of 25, which is negative 25. So now we have different signs, so we're going to take the sign of the larger number. Which is bigger, 6 or 25? 25 is bigger, so our answer is going to be negative, and then we just want to find the difference between 25 and 6. So 25 minus 6 is 19, so the answer for this problem is negative 19. Okay? Any questions on this problem? Excuse me. So 13, we're comparing 19.9 to 19.72. Okay, so when we're comparing decimals, let's focus on the left side of the decimal. So they are both 19 point. So just ignore that. That's not going to even help us. So think about this. We're comparing 0.9 to 0.72. So in order to accurately compare decimals, they need to have equal decimal places. So 0.72 has 2 decimal places. So we need to make 0.9 become 0.90 so we can compare it properly to 0.72. Now you just look at it as 90 and 72. So 90 is greater than 72. So that means that 0.90 is greater than 0.72, which means that 0.9 is greater than 0.72, which means that 19.9 is greater than 19.72. So you want to compare decimals by getting the same decimal values in each. So greater than would be your answer here. Let's look at 14. 14 we want to round 0.211 to the nearest tenth. So the nearest tenth, you need to be able to identify where the 10th place is. And that's going to be this place here, the number to the very right of the decimal. So to round this number, we're going to look at the number to the right. If that number is from 0 to 4, we're going to keep, excuse me, we're going to keep the number the same. If that number is 5 through 9, we're going to round up. So we're looking at the 1. So that number is between 0 and 4, so that means that we're going to keep that 2 the same. So the answer is going to be 0.2. Excuse me, sorry about that. So the answer will be 0.2. Okay, number 15. We have negative 3.034 minus 7.3. So we're subtracting integers, so let's change this to adding the opposite. And then we can use our adding integer rules. So we're going to keep the first number the same, negative 3.034. Change the subtraction to addition, and then we have changed 7.3 to the opposite, which is negative 7.3. So now we are adding two integers with the same sign. So they have the same sign, so you keep the sign and add. So since they're both negative, the answer is going to be negative. And now we're just going to add up 3.034 plus 7.3. So let's line this up here vertically. 3.034 plus, when you're adding or subtracting decimals, you must line up the decimal. So 7.3. If you want to put some placeholders here, you can. And then now let's add vertically. So 4 plus 0 is 4. 3 plus 0 is 3. 0 plus 3 is 3. Just drop that decimal value, and 3 plus 7 is 10. So the answer is going to be negative, because remember we kept that sign, negative 10.334. It didn't ask us to round anything, so that's going to be our final answer. Okay, let's look at number 16. So we have negative 7.56 divided by 0.7. Okay, so first off, let's figure out what the sign of the quotient or the answer to the division problem is going to be. So when you multiply or divide and they have different signs, your answer is going to be negative. So the answer here is going to be negative whatever 7.56 divided by 0.7 equals. So now we're going to set this up using long division. So so we're going to ignore the signs because we've already taken care of that with my red negative in my answer. So 7.56 divided by 0.7. So when you're dividing decimals, this is your divisor, the number outside of the division box. We want to move that decimal however many times to make it be a whole number. But if I move the decimal out here, I have to move it in here. So if I moved it once out here, it moves once in the box, and this is where your decimal will go in your answer. So now it's like you're looking at it as 7 divided by 75.6. That's really what you're doing now. So 7 divides into 7 one time. 1 times 7 is 7. Subtract and bring down the next number, which is a 5. So now 7 goes into 5 0 times. 0 times 7 is 0. Subtract. Bring down the next number. So 7 divides into 56 8 times. And so knowing your multiplication tables is extremely helpful in this class. 8 times 7 is 56. We subtract, we get 0, so there's no remainder. So this is your quotient. So the answer is going to be negative 10.8. That's going to be your final answer. Okay. Okay, 17. 9.3 plus 8.9 times 15.8 minus 12.2. So we're going to look at order of operations to figure out what do we need to do first and then in what order. So there's no parentheses and no exponents, but we do have some multiplication. So let's do that first. So we have 8.9 times 15.8. So I'm going to write the 15.8 at the top times 8.9. So when you multiply decimals, you don't have to line up the decimals at all. You actually ignore the decimals until it's time to put them in your final answer. So let's go. So 8 times 9 is 72. So I'm going to write the 7. I'm sorry, I'll write the 2 and carry the 7. So 9 times 5 is 45 plus 7 is 52. Write the 2 and carry the 5. 9 times 1 is 9 plus 5 is 14. So now once you do that first multiplication with the first from the right digit and the second number, we're going to put a placeholder here of 0 and then do this again with the 8. So 8 times 8 is 64. Write the 4, carry the 6. 8 times 5 is 40, plus 6 is 46. Write the 6, carry the 4. 8 times 1 is 8, plus 4 is 12. So now we want to add these numbers vertically. 2 plus 0 is 2. 2 plus 4 is 6. 4 plus 6 is 0. 10, carry the 1. 1 plus 1 plus 2 is 4. Then bring down that 1. Okay? So now we have to put those decimals in. So how many decimal places were in the numbers that you multiplied? 1, 2. 2 places. So here we're going to move this 2 places. So 8.9 times 15.8 equals 140.62. So now we're going to write what we have around that. So this was a positive number. Bring down that 9.3 and then bring down that minus 12.2. Okay, so now we don't have any more multiplication. There's no division, but we have addition and subtraction. So you're going to do whatever you see first from left to right. So for this case, we have this addition to do first. So I'm going to do 140.62 plus 9.3. So remember, when you're adding or subtracting decimals, the decimals must line up. So I'm going to just put a 0 placeholder here just to help me kind of organize it. Okay, so I'm going to add vertically. 2 plus 0. Okay, 2 plus 0 is 2. 6 plus 3 is 9. drop the decimal. 0 plus 9 is 9. Then bring down the 4 and bring down the 1. So this is going to be 149.92 minus 12.2. Now, again, to subtract decimals, we have to line up the decimals. So we have 149.92 minus 12.2. And again, it's helpful to put a 0 for a placeholder. So we're going to subtract vertically. 2 minus 0 is 2. 9 minus 2 is 7. Drop that decimal. 9 minus 2 is 7. 4 minus 1 is 3. And 1 minus nothing, or bring down the 1, will be a 1 here. So your final answer is 137.72. When you're doing these problems, just really take your time when you work through them. Don't be in a rush and write slowly, because it's very easy to just go too fast and miss some steps. Let me make this bigger so you can kind of see it all together. I'll give you a second to look at that. And I need to take a quick break. Give me about 2 to 3 minutes. Just 1 second. Okay, I am back. Sorry about that. Wait. Okay, so let's keep going. Okay, 19. So it says 44% is equivalent to what simplified fraction? Okay, so 44% is the same thing as 44 over 100. And so we want to simplify this fraction. So let's think about the greatest common factor between 44 and 100. So 44 and 100 can both be divided by 4. So I could change 44 to 11 times 4. And then 100 can be 25 times 4. And so here I can cancel out those common factors. So I am left with 11 over 25. So 44% is equal to 11 over 25. Okay, 20 is asking that 0.8 is equal to what percent? So to change from a decimal to a percent, you move the decimal place 2 units to the right. Alright, so we need to put a 0 here. So So 0.8 is equal to 80%. So to go from decimal to percent and then percent to decimal, you move the decimal place 2 places. Now, if you're going decimal to percent, which would be left to right here, you will go 2 to the right. To go from percent to decimal, you will go 2 to the left. All right? Okay, 21 says what is 45% of 220? So there's a couple ways to find the percent of a number. To just get the percent of a number, we can change 45% into a decimal. So right now, 45%, the decimal would be here after the 5. So if we move that 2 to the left, we would get 0.45. So 0.45 equals 45%. Then we can take that 0.45 and then multiply it by 220. So to do that, we have 220 times 0.45. Remember, you don't have to line up the decimals when you're multiplying. So let's see. 5 times 0 is 0. 5 times 2 is 10, carry the 1. 5 times 2, 10 plus 1 is 11. Now we're going to put a placeholder here. Now, 4 times 0 is 0. 4 times 2 is 8. 4 times 2 is 8. So now we're going to add. So 0 plus 0, 0 plus 0, 1 plus 8 is 9, 1 plus 8 is 9. But we now need to have put our decimal values back in. So we had 2 decimal places, so we need to put 1, 2 here. So the answer is going to be 99.00, which is just 99. So that is your answer. So to get the percent of a number, change the percent to a decimal, and then multiply that decimal by that number. Okay. So 22, we're comparing fractions. So it says Molly completed 5/9 of her homework, and Max completed 7/12 of his homework. Who completed the most homework? So we're going to choose greater than or less than. So I think it's probably easier to change the fractions to decimals and then compare the decimals. So let's see, 5 divided by 9. Let's figure out what that would be. So 5 divided by 9. Okay, so we can't divide 9 into 5. The decimal's here. Let's add a 0. So 9 divides into 50. 4, 5, 6, 5 times, because 5 times 9 is 45. And then I'm going to subtract. 50 minus 45 is 5. And then we're going to add a 0 and bring that down. 9 goes into 50 5 times. 5 times 9 is 45. Subtract, we get 5. Add a 0. So if you notice, we see a pattern here. It's going to be 0.555 repeating. All right, let's get one more in there. 9 goes into 50 5 times. 5 times 9 is 45. And it just keeps going. So 5 divided by 5/9 is equal to 0.555 repeating. And we can always round that based on what 7 divided by 12 is. Let's look over here. So 7/12 is the same thing as 7 divided by 12. So the decimal for 7 would be here, but 12 can't go into 7, so let's add a 0 here. And now let's think. 12 goes into 70. 12 times 5 is 60. So 12 times 6 would be 72. That's too big. So 12 divides into 70 5 times. Because 5 times 12 is 60. I'm going to subtract. 70 minus 60 is 10. And then we're going to add a 0. Okay. So 12 divides into 100. Let's see. 12 times 5 is 60. Times 6 is 72. 12 times 8. Well, we know 12 times 10 is 120. Let's see. 12 times 9. Let's try that. 2 times 9 is 18. Carry the 1. 9 times 1 is 9. Plus 1 is 10. So 9 is too big. Let's do 12 times 8. That's probably the one we need. 2 times 8 is 16. Carry the 1. 8 times 1 is 8. Plus 1 is 9. So that's what we want, 8. 12 goes into 100. 8 times 12 is 96. If you subtract, you get 4. But we can actually stop here, because we'll say 7 twelfths is equal to about 0.58. But we already found that 5 ninths is 0.55. So that means that the first fraction, 5 ninths, is less than 7 twelfths. All right? So 5 ninths is less than 7 twelfths. So again, I would change the fractions to decimals and then compare the decimals in order to make a good comparison of the fractions. Okay? Let me leave that up there for just a second in case anybody needs to write that down. Okay. All right, so let's keep going. (23) 7 twelfths plus 1 ninth. Okay, to add or subtract fractions, you must have a common denominator. Let's get the least common denominator between 2 and 9. So that's basically the least common multiple between those two numbers. So just to show you what I mean, if I think of my multiples of 2, that'd be 2, 4, 6, 8, 10, 12, 16, 18, 20, and so forth. Multiples of 9 would be 9, 18, 27, and so forth. So the least common one would be 18. So we want to change 7 over 2 to be an equivalent fraction to something over 18. And we want to change 1 ninth to be an equivalent fraction with a number over 18. So 2 times 9 gives me 18, so I have to multiply the top by 9 as well. So 9 times 7 is 63. Okay, and then 9 times 2 is 18, so I have to multiply the top by 2 as well, and 1 times 2 is 2. So now that I have those common denominators, I'm going to keep that denominator and then combine the top, 63 plus 2. And then 63 plus 2 is 65, so I have 65 over 18. And I can leave my answer just like that, because the test actually says to write it as an integer or reduced fraction. So that means that we do not want to get that as a decimal. And if you use the least common multiple to add it, then you know that your final answer is actually reduced already. So you're good to go. The answer is 65 over 18. Okay, 24, negative 8/11 minus 1/4. Okay, so we are subtracting integers. Let's change this to adding the opposite. So we're going to keep the first fraction the same, -8/11. Change subtraction to addition, and the opposite of 1/4 is -1/4. So we are adding integers with the same sign, so we're going to keep the sign and then add 8/11 plus 1/4. That's going to go in here. So again, we have to have common denominators. So we need to get equivalent fractions using that common denominator. So the least common denominator between 4 and 11 is going to be 44. All right. So how can I get 44? What can I multiply 11 by to get 44? 4. So I multiply the top and the bottom by that to get my equivalent fraction. So 8 times 4 is 32. And over here, 4 times 11 equals 44. So I multiply the top by 11 as well. So 1 times 11 is just 11. Now that you have that common denominator, we keep that denominator and then combine the top. 32 plus 11. And 32 plus 11 is 43. It's going to be over 44. But remember, our answer was going to be a negative answer. So this would go in parentheses. So basically your answer is -43/44. And that's your final answer. Okay, 25 1/16. That looks so bad. Let's try that again. (1/16) times -4/5. So the parentheses means you're multiplying. So you're multiplying different signs, so your answer is going to be negative. End of story. So now all you have to do is multiply 1/16 times 4/5. So we could multiply straight across. We could even look for ways to reduce before multiplying together. So I have 4/16 here. 4 and 16 have a common factor of 4. So 4 divides into 4 one time, and 4 divides into 16 4 times. So we can write that as 1/4 times 1/5. And now we can multiply straight across. 1 times 1/4 times 5, which would be 1/20. So your final answer here would just be negative, because we kept that we took the sign, we're multiplying different signs, so the answer is negative. Negative 1/20. All right. 26. We have 1/3 plus 5/6 times 3/2. So we have multiple operations here, so we want to think about our order of operations. So we don't have any parentheses nor exponents. We do have multiplication, and the only other operation is addition. So we're going to have to do that multiplication first before we deal with the addition. So that's going to be here. So 5/6 times 3/2, we can actually simplify common factors in the top and bottom. 3 and 6 have common factors. 3 can go into 3 once, and 3 can go into 6 2 times. So we actually have 5 times 1/2 times 2. And that actually equals 5/4. So we have 1/3 plus 5 over 4. Now we're ready to deal with an addition. So to add fractions, we must have a common denominator. So 3 and 4 have a common multiple, the least common multiple of 12. Because remember, if you have 3 and then you have 4, multiples of 3, 3, 6, 9, 12, 15, and so forth. Multiples of 4, 4, 8, 12, 16, and so forth. The least common one would be 12. So 12 is going to be our least common denominator. So now 3 times 4 is 12. So I'm going to multiply the top by 4 as well. So 4 times 1 is 4. And 4 times 3 is 12. So I'm going to multiply the top by 3 as well. Whoops. Okay, so 5 times 3 is 15. So now that we have those common denominators, we're going to keep that denominator and combine the top. So 4 plus 15 is 19. So we have 19 over 12. That's going to be our final answer. Okay, any questions? All right. Okay, let's keep going. Okay, 27. 7 over 6 minus 3 over 5 squared. Okay, so we want to follow order of operations. So we're going to deal with our exponent first. So this is going to be 3/5 times 3/5 that we're going to take care of first, which is going to be 9 over 25. So it's going to be 7 over 6 minus 9 over 25. Okay, so now we want to get common denominators so we can subtract these fractions. So the least common denominator is actually going to be, let's see, 5. And I'll give you a hint. If you ever have trouble getting a least common one, a common denominator can be just the product of the denominators. So let's see what that would be. 25 times 6. 5 times 6 is 30. Carry the 3. 6 times 2 is 12. Plus 3 is 15. Let's see. We're going to use 150. That may or may not be the least common one. I think it is. But if you ever need a common denominator, just multiply the denominators to get you somewhere. Okay, so 6 times 25 is 150, so I'm multiplying by 25 at the top. That would be 175. And then I'm going to multiply by 6 here. 9 times 6 is 54. So now that I have common denominators, I'm going to keep that denominator, and then I'm going to combine the top. 175 minus 54. So 175 minus 54. 5 minus 4 is 1. 7 minus 5 is 2. Bring down the 1. So I'm going to have 121 over 150. And that's going to be my final answer because I can't reduce further. If you're not sure, you can do a factor tree. But 121 doesn't have any common factors with 150, so that's going to be the final answer. Okay, so let's keep going. Okay, 28 negative 1/9 minus 2/3 plus 4/5. Okay, so we want to work in the parentheses first. So we have to have a common denominator. That common denominator is going to be 15. That's the least common multiple between 3 and 5. So 3 times 5 is what I'm going to use to get my numerator here. 3 times 5 is 15, so 2 times 5 is 10. 5 times 3 is 15, so 4 times 3 is 12. So 10/15 plus 12/15 is 10 plus 12 over 15, which will be 22 over 15. So I have negative 1/9 minus 22 over 15. So if I change that to adding the opposite, that'll be negative 1/9 plus the opposite of 22 over 15, which is negative 22 over 15. Okay, so now here I am adding integers. They are the same sign, so I'm going to keep the sign. So it's going to be negative, and then you're just going to add up the fractions. So you're going to add the fractions ignoring the signs because we already took care of it out here on the outside. Okay, so in order to get common denominators, no, in order to add fractions, we have to have common denominators. So remember I said if you want, you could just think about, you could multiply the denominators. Let's think about it a little bit more because I don't think we want to get those big of numbers. So let's see, 9 and 15. 15, think of multiples of 15. So 15, 30, 45, 60. Well, I know that I can divide 9 into 45 because 9 times 5 is 45. Right? Yeah. Yes, 9 times 5 is 45. So I'm going to go with 45 as my least common denominator. Okay, so 9 times 5 is 45, so I'm going to multiply by 5 at the top. And then 15 times 3 gives me 45, so 22 times 3 is 66. And so now my answer is going to be negative 5 plus 66 at the top over 45. And 66 plus 5 is 71, so it's going to be negative 71 over 45 for my final answer. Let's take a look at that. Okay. Okay, 29. Negative 7 over 12 minus negative 3/5 plus 3 over 4. Okay, so work in the parentheses first. So I want to get a common, first of all, I have different signs, so I'm going to take the sign of the larger number. Well, what's the larger number? You know, you got to think about what that actually is. 3/5 and 3/4. If you're not sure, we can change them to decimals. Okay, so it may be a way to do it to estimate it. Let's see if estimating it helps us. Okay, so I'm going to divide this into fourths. And if I take that same shape, divide it into 1, 2, 3, 4 fifths. So 3/4 would be these 3, and 3/5 will look like that. Another way to compare them, so I think 3/4 is bigger than 3/5. Another way to do that is to get equivalent fractions with the same denominator. So if I were to change 3/4 to something over 20, if I multiply by 5 over 5, I'll have 15 over 20. If I change 3/5 to a number over 20, multiply by 4, so I have 12 over 20. So this also confirms that 3/4 is larger than 3/5. So since 3/4 is larger, that's the larger number. So we're going to take the sign of the larger. So the sign here is going to be positive. And they were just going to take the difference between 3/4 and 3/5. Now, which one's bigger? 3/4. So I'm going to subtract, I'm going to say 3/4 minus 3/5. Okay, because you see right here, make sure you can see what I'm doing. You see right here that this is bigger than this one. Alright? So I'm going to subtract, we're going to say 3/4 minus 3/5. And I already got equivalent fractions. That's the same thing as saying, oops, 15 over 20 minus 12 over 20, which would be 3 over 20. So your final answer here is going to be positive 3 over 20. So let me take this over here and keep going. So negative 7 over 12 minus a positive 3 over 20. Okay, that's positive. So again, we are now combining these fractions. We are subtracting, so if we change that to adding the opposite, negative 7 over 12 plus the opposite of 3 over 20. So we're adding integers with the same sign. So we're going to keep that sign, which is a negative, and then just add up 7 over 12 plus 3 over 20. And again, in order to add fractions, we must have a common denominator. So between 12 and 20, let's see, 20, it's got 20, 40, 60, 80, and then multiples of 12 be 12, 24, 36, 48, 60. So 60 will be our least common denominator. And so let's think about how to get 60. 12 times 5. So that would be 35 over 60. And 20 times 3 gives me 60. So that'll be 9 over 60. So the answer is going to be negative, whatever the sum of those numbers are. So we have 35 plus 9 is 44 over 60. And it's a negative 44 over 60. But we want to always simplify this and reduce it. So I can reduce these by a common factor. Let's see, I know they are both even, so I can divide them both by 2, but I can also divide them both by 4. It's the same thing as saying 4 times 11, and it's the same thing as saying 60 is 4 times 15. So the 4's cancel out, and I just have negative 11 over 15. Let me make it so you can see the whole thing. Wish it could be, oh, I don't want to do that. I wish I could not make it that. That didn't help. Okay. All right, so just to do a recap, we started in parentheses. So we had negative 3/5 plus 3/4. We want to check and see which one is the bigger fraction. We determined that 3/4 is bigger than 3/5. So when you're subtracting, when you're adding different signs, you take the sign of the larger. So we figured out which was larger to tell us our answer is going to be positive. You take the sign of the larger, and then you find the difference. You subtract. So we then subtract 3/5 from 3/4, and that got us 3 over 20 in the gray here. So now we go back to our original, and it's negative 7 over 12 minus 3 over 20. So we have the same sign, so we add and keep the sign. So we kept the negative, and then we have to add 7 over 12 plus 3 over 20. So we got those common denominators, which ended up being 44 over 60. But then we want to always reduce it, so we simplify negative 44 over 60 into negative 11 over 15. So negative 11 over 15 is your final answer. Okay. So now, let's go on to the next one, which would be 30. So we have an expression that we're going to simplify. So now we're going to get to the algebra part of the final. So here we're going to distribute the 4 into this expression, x plus 2. So that's 4 times x plus 4 times 2. And then now we're going to distribute this negative 12 inside this expression, x minus 7. So it's going to be negative 12 times x. And then we're going to have negative 12 times negative 7. Okay, so 4 times x is 4x. 4 times 2 is 8. Negative 12 times x is negative 12x. And then negative 12 times negative 7 is positive 84. Okay, so now we want to combine like terms. So we have 4x minus 12x. And then we have 8 plus 84. Okay, so 4x minus 12x is going to be negative 8x. Different signs, so we subtract and take the sign of the larger number. So it's going to be negative 8x. And then 8 plus 84 is just 92. So your final answer is negative 8x plus 92. here's number 31. Negative 8x equals 16. So we're trying to solve for x. So we have negative 8 times x equals 16. So we're trying to figure out what value would x need to be. If I multiplied it times negative 8, I would get positive 16. So I want to undo this operation of multiplication. So to undo multiplication, I'm going to divide. So I want to get x by itself, so I'm going to divide negative 8x by negative 8. I want to undo that multiplication by dividing by negative 8. Because I want the left side to just be x equals. Now this is an equation, so that means that whatever is on the left must stay equal to whatever is on the right. So if I divide by negative 8 on the left, in order to keep this equation balanced, I have to divide by negative 8 on the right. So on the left-hand side, dividing by negative 8 cancels them out. So on the left, I just have x equals, and now 16 over negative 8 is the same thing as 16 divided by negative 8. And because I have different signs, my answer is going to be negative. And 16 divided by 8 is 2, so the answer is going to be negative 2. And you can always check your answers in an equation by plugging it back in. So the equation was negative 8x equals 16. To check yourself, plug in your solution and see if you get a true statement. So negative 8 times negative 2 is positive 16. So I have 16 equals 16. That is true, so I know that I have the correct answer. All right. Okay. So 32, negative 3x plus 5 equals 17. So I'm solving for x, so I want to get x by itself. Let's just figure out where's x. Here's x right here. So in order to start getting x by itself, I want to get that expression, the term that has x by itself. So I want to get rid of this 5 first and subtract 5. If I subtract 5 on the left of the equal sign, here's the equal sign here, I must subtract 5 on the other side of the equal sign. So now I have negative 3x, 5 minus 5 is 0, that cancels out, equals 17 minus 5 is 12. So now here, where's my x? It's right here. I want to get that by itself. So I need to undo this multiplication and divide by negative 3. So the negative 3's will cancel out. But in order to keep my equation balanced, I must divide the right by negative 3 as well. So now on the left, I just have x equals, and then 12 divided by negative 3. And so when you're multiplying or dividing different signs, your answer is going to be negative. And 12 divided by 3 is 4, so the answer is going to be negative 4. Okay? Okay. 33, we have negative 4q squared. And we want to evaluate that for when q equals negative 5. Okay, so what this means is that we're going to plug in this value for q into the equation. So it's going to be negative 4 times negative 5 squared. So from here, we want to follow our proper order of operations. So we need to deal with the exponents first. So that's going to be negative 4 times negative 5 times negative 5. That's negative 5 squared. This is this. Okay, so what's negative 5 times negative 5? That is positive 25. So now I have negative 4 times positive 25. And negative 4 times 25, I have different signs when I'm multiplying, so my answer is going to be negative. And then I want to multiply 4 times 25, which is 100. So negative 100 is your answer. Okay, 34. Oops. So I have the temperature conversion formula. It's given to you. C equals 5 times F minus 32, all divided by 9. So this is, the C represents Celsius temperature, and F represents Fahrenheit temperature. And so this question wants you to find Celsius, find the Celsius temperature, if the Fahrenheit temperature is 59 degrees. So this information tells us something important. If the Fahrenheit temperature is 59 degrees, that means that F equals 59. And we want to find the Celsius temp, so we want to solve for C. And it's already set equal to C. So all we want to do is take our formula and plug in 59 in for F. And then from there, we're going to just simplify this equation, this expression in this equation. So we have 59 minus 32. Let's see. 59 minus 32. 9 minus 2 is 7. 5 minus 3 is 2. So we're going to have 5 times 27, all divided by 9. Okay. So we could multiply 5 times 27, or we could even look at how we can reduce something. So 27 and 9 have common factors. 27 can be divided by 9. 9 goes into 27 3 times, because 3 times 9 is 27. And 9 goes into 9 1 time. So look how much simpler we made this. That's going to be 5 times 3 over 1. And 5 times 3 is 15. So that's our answer. So 59 degrees Fahrenheit is equal to 15 degrees Celsius. And that's going to be our answer. Or yes, you could have said 5 times 27, get a large number, and then divide that by 9, and then you would get 15. But this was just a way to reduce it to get the answer in a simpler way. Okay. So 35 is a word problem. So Ethan and Sierra were driving to a business meeting. Actually, let me type this up real quick. It'll be so much easier and neater than me typing up. Than me writing it. So just give me a quick second to do that. Okay. Okay. This needs to be smaller. Okay. Great. Much better. Okay, so Ethan and Sierra were driving to a business meeting 290 miles from their office. Ethan drove the first Y miles, then Sierra drove the rest of the way. Write an algebraic expression of how many miles Sierra drove. So for this tells you that we do not need to algebraic expression. Whoops. Okay. Algebraic expression means that this is not an equation. So that means we do not need an equal sign. All right, if it said an algebraic equation, that means A, you would need more information, and you'd want to have equal sign. Okay, so Ethan and Sierra were driving to a business meeting 290 miles from their office. So let's say this is their office, and here is the meeting, and then the meeting is 290 miles away. Okay, Ethan, let's make him green. Ethan drove the first Y miles. Let's say Ethan drove from here to here, and that's Y miles. Then Sierra drove the rest of the way. So this is Sierra. Write an algebraic expression of how many miles Sierra drove. So Sierra, if you want to, let's say that Ethan drove 90 miles. Let's just say we guess that. He drove 90 miles. If the entire distance, if Ethan drove 90 of those miles, Sierra drove the other 200. So Sierra drives, so you got to get 290 miles, but take away whatever Ethan drove, which was Y, and this would tell you how much Sierra drove. That equals what Sierra drove. But all they want is the expression of how many miles she drove, so all we need to write is this part. Okay? So the answer is 290 minus Y. That represents what Sierra drove. Okay? Any questions about that one? Okay. All right, I need to type this one as well. That's question number 36. Okay, so this one is a multiple choice problem. Let's see if I can express the answer choices. I'll just have to write these down neatly. Okay. Okay, let me write these down. Okay. That's so small. Okay. All right, so Meredith and Catherine were putting up some fencing across their ranch. They know that for every 119 feet of fencing, they will need 7 posts to hold it up. Which of the following proportions is set up correctly to find the number of posts it will take to put up 187 feet of fencing? So for proportions, you're basically comparing via a ratio two different things. So for the things here, that is feet, number of feet fencing, the amount of fencing, no, the length of fencing, right? And then the number of posts. So fencing versus posts. So when you're doing proportions, it's important that your proportions are like matched up. So if you were going to do feet of fencing divided by the number of posts, it would have to be equal to the exact same units. Fencing over posts. Or it could be reversed. You could say posts over fencing equals posts over fencing. What you do not want to do is say something like fencing over posts, and then set that ratio equal to posts over fencing. This would be wrong. Okay? Wrong, wrong, wrong. Okay? Because the ratios aren't lined up correctly. Alright? So this would be okay. This would be a no. Okay? So as long as they're set up, lined up properly. So let's just look at what we have and see. So 119 in option A represents the fencing. So I'm going to use red for that. And so 119 feet is, they need 7 posts. So 119 over 7 makes good sense because it'll be 119 feet for every 7 posts. Okay? So the question said, which of the following is used to find the number of posts So that means our variable X represents the number of posts. So wherever you see X, that represents the number of posts. So for option A, this X represents the number of posts for 187 feet. That would be here. So you see how it's not lined up properly? So this would not work. Okay? I'm just using the colors to kind of, help you compare. Let's look at B. So B, it has fencing over fencing. That's okay, as long as it's lined up. So for 119 feet of fencing, that needs to line up with the number of posts for that number of fencing. So that should be 119 at the top on the left, and it should be a 7 at the top on the right. But it's not. So I'm going to call this fencing A and fencing B. Well, X goes with fencing B. So I'm going to call this number of posts B over number of posts A. So you see how the A's are not lined up. The B's are not lined up. So this would be no. I hope this whole A-B thing is making some sense. Okay, let's look at the next option. So X represents the number of posts, okay, over the number of feet for the other situation. So that's weird. Okay. So then 7 represents the number of posts in the other situation. So this is just a no. This would be a no, because that doesn't even make sense. They completely mixed that up. Let's look at D. So 7 over 19. So this is the number of posts over the amount of fencing. Good. Equals X is the number of posts. Good. Over the other amount of fencing. So this one lines up good. So the answer choice here is D. For this problem, you don't have to actually solve it. You're just choosing the correct proportion. So remember that it has to line up. So just like how I said, this, let me show you again. This also could have been number of posts over fencing. And that would need to be equal to the other situation's number of posts over fencing. So this would be okay as well. So the point is just that you have to have it lined up the same for a proportion to work. Okie doke. Okay, question number 37. Okay, so Jennifer wants to get better in shape. So she decides to go to a gym that advertises 7 training sessions for $400. How much will it cost for 49 training sessions? Okay, so you could set it up like a proportion. So the number of training sessions, so 7 over 400 is equal to the number of training sessions over that amount. And how much? We're trying to find out how much. That's a number value. So that would be down here, and we don't know that value, so that's going to be X. And so we have 7 training sessions for $400. That's set proportional to 49 training sessions over X number of dollars. So we want to solve for X. So to solve this proportion, we're going to cross multiply. So we have 7 times X, 7X equals 49 times 400, well 49 times 4, 9 times 4 is 36, carry the 3, 4 times 4 is 16, plus 3 is 19, and then we're going to add those zeros. So 196, 0, 0. So now to solve for X, we're going to divide by 7. And then we're going to figure out what 196, 19,600 divided by 7 equals. So 19600 divided by 7. So let's see, 7 goes into 19. How many times? 2 times. 2 times 7 is 14. We're going to subtract. Bring down that 6. 7 divides into 56 8 times. 8 times 7 is 56. Subtract, that's 0. We want to keep going until we get to the end of this number. So 7 goes into 0, 0 times 7 is 0. Then we have one more 0. So our answer is going to be $2,800. Another way you could have done that is that you could have said, okay, 7 training sessions for $400. How much for 49 training sessions? Well, how many 7 can go into 49? 7 times. So you could say, okay, 7 times 7, well, you can't see that. Okay, so you could have said, all right, 7 goes into 49 7 times. So how many groups of 7 are in 49? 7. So you could do 7 times 400. That would have also gotten you straight to 2,800. It's another way you could solve this problem. No better way, just whatever makes most sense to you. Okay, leave that up there for a second. Okay. All right, 38. Find the area of a rectangle with a length of 23 meters and a width of 14 meters. So the area of a rectangle equals length times width. So we would just multiply those values together. You will not have a formula sheet, so you do want to be familiar with those more basic area formulas. So let's see, 23 times 14. 4 times 3 is 12, carry the 1. 4 times 2 is 8, plus 1 is 9. Then we're going to include a 0 placeholder. 1 times 3 is 3. 1 times 2 is 2. Then we're going to add. So 2 plus 0 is 2. 9 plus 3 is 12. Carry the 1. And 1 plus 2 is 3. So the area of this rectangle is going to be 322. And since they were in meters, it would be square meters. For this problem, they will provide you with the units, so you would only have to enter the number in IMath AS. Okay, let's look at 39. So we have a circle, and then we have a radius of 5 inches, and it says to find the area. Why is my writing so bad sometimes? Okay, it says to find the area of the circle, and they tell you to use 3.14 for pi. So the area of a circle is pi r squared. So r is the radius. So in this case, r is 5. And we're going to use 3.14 for pi. So it's going to be 3.14 times 5 squared. So we're going to do the exponent first. 5 squared is 25. So it's going to be 3.14 times 25. So if I do that on the side here, you can ignore the decimal values when you multiply because you're going to add them back at the end. So 5 times 4 is 20, carry the 2. 5 times 1 is 5, plus 2 is 7. And 5 times 3 is 15. I'm going to put that 0 placeholder. 2 times 4 is 8. 2 times 1 is 2. And 2 times 3 is 6. So now I'm going to add vertically. 0, 7 plus 8 is 15, carry the 1. 1 plus 5 is 6, plus 2 is 8, and 1 plus 6 is 7. Now it's time to go back and add those decimals. So this was 1, 2 decimal places, so that's 1, 2 here. So the area of this circle is going to be 78.50. 78.50. It says round to the nearest tenth, so we can just say 78.5. Okay? Alright, and the last problem is a conversion problem. So it says to convert the measurement. So we have 9,336 millimeters equals how many kilometers? So they're going to give you some conversion tables to choose from. Okay? Alright, so we are given a few things. So we have, and let me use some abbreviations here. So this is 9,336 millimeters equals how many kilometers? Okay, so this is what they give us on the side. They say that 10 millimeters equals 1 centimeter. That 100 centimeters equals 1 meter. And 1,000 meters equals 1 kilometer. Okay, so we're going to start off with the amount that we are given. We want to multiply that by some ratio that's going to cancel out the millimeters and get closer to kilometers. So we can go from millimeters to centimeters. Okay? So let's see, 10. So if you're going to multiply that by a ratio, we want millimeters to be in the bottom, and we're going to have centimeters at the top. And the reason why is because I want for the millimeters to cancel out, and I want to be left with centimeters. So that's going to be 10 millimeters for every 1 centimeters. And I'm getting that. I'm getting this from this. Okay. But then I also want to convert to kilometers. So now I want to have the centimeters cancel out, so I'm going to put that on the bottom, and I want to end up with kilometers, so I'm going to put that at the top. Because you'll see here the centimeters will cancel out, and I'll be left with kilometers, which is what I need. Now, what numbers do I put in here? Okay, so let's see. Oh no, I need to go to meters. I skipped meters. Sorry about that. I skipped meters. Okay, so the centimeters go at the bottom, but then centimeters convert to meters. Okay, so now let me use this information. So for every 100 centimeters, you have 1 meter. Because the centimeters will cancel out, and we'll be left with meters. Let's start with that because I'm running out of space. Well, I guess I could keep going. No, we'll keep going. Okay, so, but I want to end up with kilometers. So I'm going to multiply that by, I want meters at the bottom because I want that to cancel out, and I want to end up with kilometers. So these are going to cancel, and I'm going to be left with kilometers. But what numbers will go in there? So if I look back here, 1,000 meters for every 1 kilometer. So this will be 1,000 for every 1 kilometer. So let's look at what's happening here. 10 times 100 times 1,000. So if you were to multiply those together, just combine the zeros. That's the easiest way to do it. So the top part, 9,336 times 1 times 1 times 1 is just 9,336, right? Over 10 times 100 times 1,000, you can just combine those zeros and then that is your fraction, and you're going to end up with kilometers. Okay? Now, let's think about when you're dividing by a power of 10, right? The easiest shortcut way to handle that is to say, okay, if this is going to be divided by, what's this, 1 million, you're basically taking that 9,336 and then you're going to move the decimal however many zeros you have. So you have 1, 2, 3, 4, 5, 6. Dividing this by 1 million is the same thing as moving the decimal 1, 2, 3, 4, 5, 6 times. Okay? So what does that end up being? So you need to put 0 placeholders there. So you would have 0.009336 kilometers. And that is your final answer. So this really is just trying to see if you understand the whole way that you convert and how you line up your units. And let me use my colors here. This is how I got that in red. So I started with millimeters, and I put the next fraction, I multiplied it by centimeters over millimeters, so the millimeters would cancel out. And then I put the next fraction as meters over centimeters, so the centimeters cancel out. And the next one, I wanted the meters to cancel out because I want to end up with, I wanted kilometers as my final answer. So that's what I wanted to end up with. I don't want that canceling out with anything. And that's what I have here in my answer. But you'll be given this information. This is given. You won't have to remember that information. So that was a final exam review. So it was a lot. I wanted to do it a little earlier so you can start processing it and practicing it now. The review is available for you to practice on in iMathAS. I suggest that you do that as many times as you would like. The grade will populate into the grade book automatically, but it will change as the grade changes. So if you tried a few questions and you only got like 5 right and you have a 5 out of 40 in the grade book, don't freak out. When you keep doing more, it will update. Okay? Because your midterm review, no, your final exam review is like a lab grade for you in this class. So you want to practice it a lot to help you overall in the final and to maximize your grades. So I'm going to get this posted shortly. It's a little long, so it may take a little while for it to download, but I will post this into the Blackboard course as soon as possible so everyone can view it. So if you have any questions, you know what to do. You can email me, you may call me, and make sure you post on the final exam discussion board. If you haven't already, I'm going to start going through there and answering any questions that haven't already been answered by your colleagues. So hope you all have a great week, and I will see you later. Bye. No problem. Thanks for sticking it out with me.